Hi guys, I'm sorry I couldn't be in class today. Wait, for some reason that was echoing. Sorry. Sorry I couldn't have been in class today, but I wanted to just give you the lesson. Okay. First, I want to review what we did previously. Remember, we were talking about inverse trig functions. Okay. So, for example, if you have the arc sine of, let's say, 1/2. Okay, what is this question asking? This question is asking what angle has the value of 1/2? Okay, and that's my favorite, pi over 6. Now you might be sitting there and saying, wait a minute, I remember the unit circle. I know there's at least two angles that have the sign of 1/2. But remember, we restricted the domains. In fact, I saw this from another teacher and I think it's pretty cool. If you want to find the arc sine or the inverse of sine, remember you're only going to go from negative pi over 2 to positive pi over 2. If your angle is positive, you're going to look for the angle here. I'm sorry, if the value is positive, you're going to look for the angle here. If the value is negative, you're going to look for the angle here. We have the inverse of cosine. If you remember, cosine went from 0 all the way to pi, 0 to pi. If the angle value, if the value was positive, so I keep saying that, it's late, I'm tired. If the value is positive, it's here. If the value is negative, the angle's located here. And then you have the inverse of tan. And tan was almost the same thing as sine, okay, except we didn't include negative pi over 2. Notice how I'm putting an open circle here. And it goes to, with an open circle, pi over 2. Positive values here, negative values here. Okay, the reason why we don't include these two is because there's asymptotes on the graph. All right. If you look at this, sine, cosine, tangent spells out D. Yeah, that looks like a D, A, D. So you could remember where to look. Okay, so I just want to bring you to another area, okay, where we didn't actually use reference angles. So for example, you're given tangent of the inverse cosine of 3 over 5. Okay, we know 3 over 5 is not one of our reference angle answers. Our reference angle answers were, 1 over 2, radical 2 over 2, radical 3 over 2, 1 or 0. We have 3 over 5. So we're going to do something else. What we're going to do is we are going to build a triangle. Now, we're going to start here because remember when we did these two-step problems, we always, order of operations, solve what's in the parentheses first. So I'm going to build a triangle and I'm looking for the angle. Remember, I'm looking for the cosine. Some angle is 3 over 5. Since 3 over 5 is positive, I'm going to build it in quadrant 1. So here we go. I'm just going to build a triangle in quadrant 1. Here's my theta. Cosine is defined as your adjacent over your hypotenuse. So I'll put 3 here. I will put 5 here. Now, I honestly don't care what this angle is because remember, I want the tangent of whatever this angle is. So even though I don't know what that angle is, technically I now want the tangent of that angle. And I could just get that information from this triangle. Tangent is opposite over adjacent. So what I have to do is I have to do a little Pythagorean theorem to find out what the opposite is. But of course, I'm a student in pre-calc, and I know that if one leg is 3 and the hypotenuse is 5, that this side's going to be 4. And my tangent's going to be opposite over adjacent. And that's the answer. So we're actually not really solving in here. We're just building the triangle so we can use that information to get that answer. Okay, because I really don't need to know it. I just need to know theta And now whatever theta is, I want to find the tangent of it. I don't care what theta is. I just want to know its tangent. That's theta. Again, we'll try another one. We'll do the cosecant of the arc sine of 5/13. Okay, again, we're going to build a triangle. I spelled triangle wrong. It's positive. Sine is positive in quadrant 1. So I'll build my right triangle. Here's my theta. Sine is opposite over hypotenuse. 5/13, which is 1 month from today, which is my birthday. 1 month from today, just saying. All right. And now I really don't care what this angle is. Okay, because I need to find out what the cosecant of that angle is. Once I solve this, all I really want is to find the cosecant of that angle. Well, we can't find the cosecant until we find the sine. Oh, look how easy this ended up to be. I already have the sine. Cosecant and sine, what am I talking about? They're inverse right there. So I know the sine is 5/13. So this is going to be 13/5. Oh, how easy was that? I didn't even realize it. All right. For those of you who are wondering, of course, the other side would have been 12. Let's try another one. Let's try the sine of the arc tan of -7/5. Okay, so I'm going to build a triangle. Tangent is negative. Tangent is negative in quadrant 4. So when I build my triangle, I'm building it this way. Remember, we always go back to the x-axis. Here's my theta. Tangent is opposite over adjacent. So it's -7/5. And now I want to know the sine of this angle, the sine of whatever this angle equals. Okay, so this technically is just theta. So the sine of theta is, well, sine is opposite over hypotenuse. But I don't know the hypotenuse. So let me do a little Pythagorean theorem here. 5 squared is 25 plus 49 is going to give me 74. So this is square root 74. So the sine is going to be -7 over radical 74. But of course, we're not savages. We don't leave our radicals in the denominator. So I will simplify that to 7 radical 74 over 74. Not the most gracious number, but that's the answer. Okay, so in your homework sheets that I gave you in the last class, okay, there were a bunch of problems that I told you not to do. Okay, I'd like you to go and do them now. Okay, so on those papers that I gave you, can you please do those problems that we left off? Okay, I do believe it was something like, I don't have the paper in front of me, I'm sorry, but it was maybe 16 to 24. Okay, so what you're going to do is you're going to build a triangle with the inside. I really don't care what that theta is. I just need that theta to find the tangent of it. I just need that theta to find the cosecant. So I really don't care what that angle measures at this point because it's just a piece of a bigger question. All right, guys, see you soon.